What I want to talk about today is changes in primary production and scallop habitat on the Northeast continental shelf. And so there's going to be kind of two sections to this talk. One is kind of talking about what the source water has been over the years and how that has been observed to be changes and some of the ramifications of that. And then we're going to also talk about scallop habitat. Yesterday, I kind of talked to Farrell. I asked him a question about how they selected their sites, what makes good scallop habitat. And that's something I think we've been wrestling with for a long time. But hopefully we can dig in and try to disentangle this. So as you guys know, scallops are filter feeders, right? And they rely on phytoplankton in the water column to survive. There are a lot of things that influence this phytoplankton, and one of which, according to some of the work that Kevin has recently done, is shifts in the Gulf Stream and how that has influenced the water masses that come into the Northeast Channel, into the Gulf of Maine, and then distribute out through the system. And so these changes in the Gulf Stream have really fundamentally changed and shifted the ratio of cooler Labrador current water and then warm slope water. And I'll talk a little bit about how those different water masses influence primary production and their potential influences on scallops. So this is a time series of the contribution of the warmer, saltier water and also the cooler, fresher water from the Labrador current. And you can see this time series as it moved forward since about the mid-90s. It kind of bounced around the middle. Cooler, fresher waters. And so what impact did that have on the system and the productivity that we've observed? So this is quite a bit of graphics here, but I think it tells an interesting story. The addition of this warm water through the Northeast Channel has resulted in a regime shift. As you think back on the graphic I showed in the previous slide, around 2010, there was that change from cooler water, or from kind of a very variable response to warmer water versus cooler water. And so if you look at the different regions on the Northeast Shelf, this is the Northeast Shelf in aggregate, and we can look at Maine here in this panel, Georges Bank, and then Mid-Atlantic North and Mid-Atlantic South. The takeaway message here is that we saw an increase in temperature pretty much across the board right around 2012. And what did that do? I talked about how phytoplankton and chlorophyll are very important indicators of the habitat and the food availability generally, but for scallops specifically. And you can see these green lines right around that same time. There was a drop in chlorophyll across the board throughout all the regions that we're interested in talking about. So if you look here on the Northeast Shelf in aggregate, right around that time, a drop in chlorophyll. And for each region, it showed the same response. So in addition, in addition to the temperature drop and the chlorophyll drop, as determined through remote sensing, there was also observations that this was also across the board on bottom water. You can see the changes or the increases in bottom water temperature throughout some of the middle of that time series right around that time. So as the water entered in through the Northeast Channel, it warmed up, and then as it got distributed down through the shelf and through the rest of the Northeast Shelf system, that was also observed. Bottom water temperature is a little bit more difficult, and so I think to estimate or to observe, and so we have fewer observations than we would with remote sensing. So let's talk about chlorophyll a little bit. Let's talk about primary productivity. And so if you think about the 5 subregions here in that system, you have 2 in the Gulf of Maine, east and west, Georges Bank, and the northern part of Mid-Atlantic and the southern part of Mid-Atlantic. These are kind of traditional areas that oceanographers use to characterize productivity. So if you look at what the chlorophyll time series have looked like throughout all of those regions, those sub-regions, you can see right around that same time, 2012, 2015, right around 2012, there was a big drop in chlorophyll estimates. So Gulf of Maine, down, down, Mid-Atlantic, down quite a bit. We've seen a little bit of a rebound in the latter part of the time series, but there had been an era, a regime shift of lower chlorophyll production throughout the system. What does this mean? So chlorophyll, yes, okay, we know it's important food, it's the base of kind of the aquatic food chain, but there is an applied connection between fishery yields and chlorophyll. And so if you look at these graphs here, they talk about fishery yield generally, on the y-axis here, and then chlorophyll up in this top panel, and net primary production on the lower panel. And you can see there's a trend. There's a trend with higher fishery yield as a function of higher chlorophyll concentrations in the water column. And so that, to me, is an important point. You know, higher chlorophyll, higher productivity, and fishery yield follows. Breaking it down even farther, if you look at those chlorophyll A graphics and kind of try to model out some model fits, fishery yields, as we said, really kind of follow the chlorophyll concentrations. And so if you look at the differences between the amount of chlorophyll that we've observed in kind of that low part of those time series, which was around 1 milligram per cubic meter, up to where it had been in the time series, up around 1.5. Depending on how you fit the data, it could represent a pretty significant reduction in fishery yields. So talking about temperature a little bit, this is a historical time series from 1900, and you can kind of see it's bounced around a bit. There was a big bump in the early 40s, or the late 40s and early 50s, of about 1% in terms of sea surface temperature. Can we consider it similar to what we've observed recently? And what was the underlying process that was the foundation of this bump in temperature? So to kind of summarize the oceanography, the chlorophyll work, what occurred in the late 40s and early 50s? Was there a similar change in source water that entered the Northeast Shelf? And if so, did we see reduced fishery yields during that time? It's an interesting research question. But as we look forward, what are the future prospects for what water sources are going to dominate coming into the system? And what is that connection to the larger Atlantic circulation and conditions in the Arctic? I think Glenn's probably going to touch on this in the next presentation. And so if we get locked into a regime where we have higher temperatures and lower productivity, there could be a potential for lower fisheries yields into the future. But I think that is a big unknown at this point. So there is that, just to kind of summarize this section, there is a connection between the water that comes in, the nutrients that are in each of those water masses, and how that impacts fishery productivity and chlorophyll production. And so these are important things to think about. Very difficult to manage this, impossible to manage this, but it's something to keep an eye on of what we might think about in terms of maybe placement or strategies to mitigate around some of this should enhancement move forward. So shifting gears just a little bit, talking about scallop habitat. And so in a recent paper by Kevin, he looked at a lot of different species based upon the NMFS trawl survey information. And so where do these species occur over time? And so if you go back and look at the beginning of kind of the trawl survey data set in the mid 70s through about 2019, you can kind of see what was going on with scallops specifically. And so Currents area is kind of where you observe scallops in the survey, and then the biomass is the biomass. And so you can kind of see that over the time series, the survey saw scallops in a lot more places than it did earlier on the time series. And so I think that's an important thing. The habitat is is supportive of the occurrence of scallops. Not to say that they're thriving in every area, but where were they observed? So here's a graphic of that, and you can kind of see where the survey information was used to model habitat for scallops. If you look at the spring and the fall surveys on the top and bottom panels, these hot colors here represent scallop habitat, as you probably know, and this is on the right panel. This is the trend in those graphics. So the red colors means there's been an increase in that scallop habitat over time. Again, drilling down into habitat of scallops a little bit more, you can kind of see from those data that the habitat area has increased over the time series as a function of the observations in the NIMS trawl survey. So we know that as habitat increased, interactions with other species also increase. And so I think the take-home message here is throughout the time series, there have been positive connections with a suite of other species. And so these monikers are a little bit, I mean, you can probably tease them out, but there has been significant overlap with other habitats for other species. And I think the take-home message is scallops are pretty resilient. We're going to talk about predation moving forward, but to know that scallops are a fairly resilient species in their system and their ecology. So this is a pretty quick summary. Hopefully you got something out of it. But to conclude, one of the things that appears to be quite important for chlorophyll production and primary production is the source water that comes into the system. And so, as I said, each one of these source waters has different characteristics, different nutrients, different salinity, different temperatures, and that has an impact on the chlorophyll that results throughout the system. And from the habitat modeling work, scallop habitat has increased over time, and the interaction areas between scallops and other species have also increased over the time series as a result of that expansion. So, I'm not sure if I can answer a lot of questions from this, but I'll do my best if you want. Hopefully that was somewhat clear. And it looks like we got some questions. Okay. I'll do my best, Devora.
All right, I have one confirmatory one, and the comment in the beginning that the thing with the chlorophyll going down. We saw in the last assessment that through early 2010, 2012, something like that, that scallops are growing like gangbusters. And recently we've seen growth slow. And I think that's very consistent with that change in chlorophyll. That's my positive one. With the habitat thing, I have some concerns. First one is to be aware that these type of models are strictly correlative, if they're not cause effect. And obviously there've been a lot of management changes that aren't really, quote, habitat, that have increased abundance. And that's not taken account. The other one, which I think is I don't know what to do with, there's a problem of using the trawl survey for scallops. Specifically, if you look at the trawl survey, the fall trawl survey catches like twice as many scallops as the spring one. Now, why is that? I think most people might guess that in the fall, the scallops are more active and they're more likely to swim, and therefore more likely to get caught in the trawl. So what he's modeling essentially is catches in the trawl survey, all right, which if the temperature goes up, that will go up without, even if abundance changes, it stays the same. So I've seen several of these models using the trawl survey, and I don't believe any of them for that reason. Honest, that it's, I mean, there's a reason why we don't use the trawl survey in the assessment. And because it has these artifacts no one who's, to my mind, I've never used the trawl survey data for scallops, but I have looked at it, and that was the first thing that jumped out on me. And people who are using it should notice that. Something's funny about the catchability. There's not more scallops in the fall than the spring. And that says the catchability is more. And you can follow that there's issues. There's also other issues that it's probably catchability is probably varies by habitat. The more places like the channel, the trawl, and we see this in the dredge, that it bounces around a lot more and there's less. And there's also dome-shaped selectivity, which you know about. Any rate, there's all those caveats. So the habitat model I have issues with.
Yeah, and I
it
think
that way.
I think that I think to me that the take home message, yeah, there's going to be some asterisks with some of these, and you know, I think as we think about this in the context of enhancement, I think really that we really want to pay a close attention to, and as I said, this is a question we've been wrestling with for a long time. What makes good scallop habitat? And not only now, not only in the past, but as we look into the future. So I think that, you know, there are different tools you can use to evaluate that, but I think that should be a component of what we think about as we think about enhancement moving forward. Hey, Eric.
Thanks, Dave. Great presentation. Did a good job. Not sure if you can answer this question or not, but last year we saw on the water very good heat yield from columns. We also had a record-breaking phytoplankton Gulf of Maine extended down onto Rudders. Is there any studies that are linking these and correlating them? It says, well, I'm reading it's 10 times higher than historical averages, is what we saw for chlorophyll on Georgia's Bank and Gulf of Maine. So it's intriguing to see the correlation between phytoplankton and scallops. Now we had a bloom that was 10 times the average. Are we studying that?
You're right. I can't answer that question, but but there may be some folks here that might have some insight on that. I mean, I think, oh, Deborah does.
We are aware of that, and I had discussions with my Canadian colleagues that they saw it too in 2023. The meat yields were off the charts. We are also aware that was a really high chlorophyll year. So that's in my queue. I just have too many things going on right now, but I have talked to our Kim Hyde, who's our phytoplankton expert, and she's got me some data. I have too many things going on right now with management and all these other things. One of the things I'd really like to look at, as apparently it is not extended to this year. I think meat yields, I don't know if the fishermen can comment on this. I think they're back to normal this year.
Yeah, I think if I recollect, our stock assessment counterpart from the Canadian side on the offshore fishery, David Keith, he's looked into kind of chlorophyll and how that might relate to yield and reproduction into the next year. So it's something that people are working on. It's something that people are aware of. I think, you know, what the work Kevin has done that I presented earlier was a little more general, but there is a lot of opportunity to really drill down, and we have some information, we have data that could support kind of a more granular analysis of that correlation between chlorophyll and scallop growth, reproduction, that type of thing. So I think that's a good maybe research area. Others are maybe doing it that I'm not aware of, but it's something that that linkage and that connection is a good one.
All right, so Melissa's got the last question, then we'll move on to the next speaker. And we do have the same setup so that after break, we'll have a panel. So if you do have additional questions, we can make sure we get those addressed.
So very quickly, if you want to change the presentation while I'm talking about this, in the sea urchin fishery in Maine, we are seeing a change in the composition of algae, and that is affecting obviously how the sea urchins grow. In herring, we are seeing, I think, a change in maybe what they are feeding on, and their condition factor is decreasing. So as we are experiencing these changes in our climate and with primary productivity, I would like to sort of question the group or just put this idea out there to those people that study this, but is the phytoplankton composition changing? And if it is, how is that impacting scallops? Are scallops still getting their optimal phytoplankton food source? And recognizing that toxic blooms in Maine has been increasing. There's also been new species of blooms in Maine, in the Gulf of Maine. I think that's also another avenue that we need to think about. And so just as we are moving forward with this topic, I think it'd be interesting for either Devorah's contact or Kevin to think about how composition of species within the phytoplankton community are changing and how that could be impacting optimal feed options for the species that it should be feeding.
That's a good point. Thank you. And I think there's definitely some work being done. I don't know if Devorah's got another. Devorah, how about can we wait maybe till the panel? Is that something that we could for your response, or we have a minute?
We'll have you first on after break. Is that all right?